Hello everyone, welcome to my YouTube video. In this video, we will discuss question number 8 of our my End Sem paper. So the A part of question number 8 is K-means clustering. So working mechanism of K-means clustering is K-means is an unsupervised iterative algorithm that partitions data points into K distinct clusters. So the initialization is select the number of clusters and randomly place K centroid. So second is assignment step. Assign every data point to the nearest centroid based on distance. So third is update step. Recalculate the position of each centroid to the mean of all points assigned to its cluster. So fourth is iteration. Repeat steps 2 and 3 until the centroid stop moving convergence or the maximum iteration are reached. So the object function minimize the WCSS, which is sigma of I to the power I is equal to 1 to k, which is and I is equal to 1 to m, and the mode of x to the power I minus mu I to the power whole square. The advantages and limitation of k means advantages: simplicity, easy to understand and implement; scalability, computationally efficient as scales well to large dataset; speed, fast convergence for well separated clusters; guaranteed convergence. The algorithm is guaranteed to converge to a local STM. So limitations are require K must specify the number of clusters, outlier sensitivity. Centroids are highly affected by outliers as they are based on the mean. So initial centroid dependence results can vary widely depending on the initial random placements of centroids. So cluster shapes only effective for spherical clusters and fails with complex shapes. Example crescent or interlobed clusters. So the B part of question number 8 is decision tree classifier. So the working principle, a decision tree is a supervised learning model that uses a tree-like structure for decision making based on training data. Key components. Root node represent the entire population. It gets split into two or more homogeneous sets. The second is internal node represent a test on an attribute. Third is branch edge represent the outcome of the test. Fourth is leaf node represent is the final class level or decision. The algorithm find the best split at each node by maximizing information gain. So the decision tree structure is like this: root node, split 1, split 2, then leaf A and then leaf B. So the entropy and information gain. So entropy measure the impurity or randomness in a set of data. A perfectly homogeneous set, all one class, has entropy is equal to 0, and a maximally mixed set has entropy is equal to 1. In the binary classification, entropy is equal to sigma of I is equal to 1 to the c pi log 2 to the pi. In the information gain, IG measures the expected reduction in entropy caused by splitting the dataset in on a given attribute. Decision tree select the attribute that yields the highest information gain to make the next split. So IGS is equals to entropy S minus sigma of values A, the mode of SV divided by S mode of S entropy S of V. So the B information. So B part of question number 8 is information gain illustration. Example: deciding whether to play tennis, yes or no, based on outlook. So initial entropy root no. Total samples is equal to 14, positive yes, negative 5. So yes is equal to 9 by divided by 14, approx is equal to 0.64, and no is equal to 5 divided by 14, approx is equal to 0.36. So entropy is equal to minus 0.64 minus 0.64 divided by log 2, 0.64 minus 0.36 divided by log 2, 0.36, so which is approx 0.940. So the initial uncertainty is 0.940. So calculating gain and on outlook, split on A outlook sunny over first rain. Outlook sunny is equals to yes no, and outlook overcast. So 4 yes 0 no, and outlook rain. So rain 2 yes and 3 no. So the if outlook is the highest IG compared to other feature, example temperature, it becomes the rule node split. Thank you for watching this video.